Okay, lesson 77 is binomial expansion. This is a really cool concept. Saxon doesn't develop it as far as it could, so I'm going to try to develop it a little bit more in this lesson. Now, if you have a binomial and it's to the 0 power, we know anything to the 0 power is 1. If we have the binomial to the first power, it's just going to be a plus b. A binomial to the second power, I don't know if you remember this little trick that I taught you. You square the first term, you multiply the two terms together, and then take it times 2, and then you square the last term. So that's what it looks like squared. Hopefully you're not going to say a squared plus b squared. If you have a binomial and you cube it, it's a cubed plus 3a squared b plus 3ab squared plus b cubed. If you have a binomial and you take it to the 4th degree, this is what it looks like. And a binomial to the 5th degree looks like this one. Now, if you look at these, you're going to see a pattern. First you have 1, and then you have 1a, 1b. Then you have 1a squared, 2ab, 1b squared. You also see that, let's just take to the 3rd power. This is going to be the one that we would use most often. You could take and multiply a plus b times a plus b times a plus b, which we've done that before. Or you can memorize a pattern and be able to do this really quickly. So the pattern for these is you just cube the first term if it's cubed. You take 3 times this first one squared times the second one, then 3 times the first one times the second one squared times the second one cubed. You'll notice on all of these the first term starts out the same degree as what we're doing to the binomial, so it's the 3rd degree, and then the first term is decreasing, so it goes 3, 2, 1, and here you can put a to the 0, which would just be 1. The second term increases from 0 b's, b to the 0 power, to b to the 1st, to b to the 2nd, to b to the 3rd. The same thing happens to the 4th power and to the 5th power. Look at this. Your first term is to the 4th power, and then it decreases the whole way down until we have no a's. The b's start with b to the 0 and increase until we get b to the 4th power. The same with the a plus b to the 5th. A starts out to the 5th, a to the 4th, a to the 3rd, a squared, a to the 1st, a to the 0, and the b goes the opposite way. B to the 0, b to the 1st, b to the 2nd, b to the 3rd, b to the 4th, b to the 5th. The only thing that's tricky here are the numbers. You'll notice we have 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. These numbers can be derived using the Pascal's triangle, which I have down here. Pascal's triangle starts out with 1. You'll notice all of these are 1s. And then, to get the middle terms, you add the 2 above it. So this will be 1. This term is formed by adding 1 plus 1 to get 2, 1. This term is found by adding these two together. 1 plus 2 is 3. 2 plus 1 is 3, and then 1. Same 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4, etc., etc. We can form our own Pascal's triangle just starting with the 1, 1. And you'll see that up here when we do these problems, like a to the 3rd, if this is to the 3rd power, these red numbers are to the power, you can see we have 1, 3, 3, 1. So 1, 3, 3, 1. If you want to raise a binomial to the 4th power, your numbers, your coefficient numbers, are going to be 1, 4th power will be right here, 4th power, 1, 4, 6, 4, 1. Now anytime I expand a binomial or I cube it, I always use this method right here instead of using multiplying it out. Sorry for the singing in the background. Okay, let's try a problem. These problems aren't in your book. Let's expand a binomial x plus y to the 3rd. So we cube the first term, so that'd be x cubed. It'd be y to the 0, so there's no y. Then, since it's to the 3rd, now we're up here, we're going to use a 3. So it's going to be 3. We're going to decrease this exponent by 1, x is squared. We're going to introduce the y. Here we go, we're going to use the 3, x, remember the x is decreasing, the y is increasing, and then finally it's going to be y to the 3rd. See how much easier that is than if we multiply this out? Let's try, I think this is the one I have below, but let's just try something like this. What if we had a 2 there instead of a y? How would that look? Well, we're going to cube the first term. We're going to get x cubed. We're going to take the 3 times, this one's going to decrease by 1, and we're going to introduce the 2. We still have our 3. We're going to decrease our x by 1, and we're going to square the second term. And then finally our last term is this second term cubed. So the x is decreasing, the 2 is our second term, it's 2 to the 0, 2 to the 1, 2 squared, 2 cubed. We can write our final answer as x cubed plus 6x squared plus, this would be 4 times 3, would be 12x plus 8. And that's how we use binomial expansion without having to multiply this all together. They don't give you very complicated ones in the book though. I just did that one. Now we're going to get down, this one is in your book. How would you do this one? X plus y to the 8th. First of all, we would need to know what numbers to use. So we go to our Pascal triangle, we need to the 8th. So we're going to go up here. I only did it to the 7th, so we're going to have to come up with our 8th row. Remember, this is easy to come up with. We start with 1, we add these two together, we get 8. Add these two, get 28. Add these two, get 6, 56. Hopefully I'm adding these right. We're going to get 70. We're going to repeat again, 56, 28, 8, and 1. So these are our numbers, 1, 8, 28, 56, 70, 56, 28, 8, and 1. I'm not going to remember those, so I'm going to come back and look at them. Let me just write it right here so I can do that. Hold on a second. Let's just put that problem right here. Okay, this problem was x plus y to the 8th. So this is going to be the 8th power, x to the 8th, plus, we're going to use this number, 8. The x is going to decrease, so it's going to be x to the 7th, introduce the y, plus 28, decrease the x's, so it's x to the 6th, y squared, plus 56, x to the 5th, y to the 3rd. You can see the x is decreasing, the y is increasing, running out of room. 56, now we're at 70, x to the 4th, y to the 4th, plus 56, x to the 3rd, y to the 5th, plus 28, x squared, y to the 6th, plus, go up there, get the 8, x, y to the 7th, plus y to the 8th. This is kind of a cool concept, easy to do if you understand it. Let's just do one more. X plus y to the 4th, so we can just make our little tree here. 1, 2, 1, 1, 3, 3, 6, 1, 4, 6. Whoops, it should have been a 1. 1, 1, 6, 4, 1. Okay, so we're going to use this row right here. This will be 0, 1, 2, 3, 4. So it's going to be x to the 4th plus 4 x cubed y plus, now we're getting our 6, decreasing our x squared, y squared, plus 4 x y to the 3rd plus y to the 4th. And you expanded this binomial very easily using this Pascal's triangle. Usually your problems will have numbers involved and it gets a little bit more complicated, like 2a plus 3 cubed. If that's the case, you just have to, when it comes to squaring or cubing, you have to square and cube the 2 also. Let's just do this one real quick. This would be 0, 1, 2, 3. Actually, this is it right here. These are our coefficients. That's a 1. In case you can't tell that. So I'm going to just take the first term and I'm going to cube it. So it's going to be 8a cubed plus. Now I'm going to use the 3 times the first term squared. So that's going to be 2a squared times 3. Plus, we have to use the 3 again. 3 times, this time it's just going to be 2a, and now we're going to square the second term, and then finally it's the last term cubed, which would be 27. And then of course you just have to simplify it. So this is going to be 4 times 12 times 3, or 9 times 4 is 36, a squared, plus 9 times 3 is 27, times 2 is 54, a plus 27. So it's much easier than writing it out 3 times or 4 times or even 8 times. So that's it for lesson 77.